Bismillahirrahmanirrahim. Fundamental of electric circuit exercise chapter 1 and question 1.6, which is the charge entering a certain element as shown in the figure. Find the current at t is equal to 1 millisecond, t is equal to 6 millisecond and t is equal to 10 millisecond. As we know from the waveform that on x-axis we have t and on y-axis we have q. So it's basically charge versus time. And we are going to find current at t is equal to 1 millisecond, t is equal to 6 millisecond and t is equal to 10 millisecond. So this 1 millisecond is between 2 and 0, and as you see, q minus 0 means 30 minus 0, 30 millicoulomb minus 0 divided by 2 minus 0 and t minus 0. So you can 30 millicoulomb divided by 2 millisecond is equal to 15, and this is t is equal to, so 15 t coulomb q is basically, or yeah, we can simply say, if you can simply write, so q of t is equal to 15, and then by putting this in the formula, dq by dt, so putting 15t here, d by dt, so we can get I of t is equal to 15 milliampere, or 15 ampere, sorry, because you can cross this. However, for point B, as we know, 6 millisecond, the response is a straight line constant at t is equal to 30 milliseconds. As we know that this is constant, basically the response is straight, we don't see any variation here. And for constant, if you find constant charge, so you can get zero current. So q is equal to 30 millicoulomb, and we can see that I equal to, as we know, dq by dt and d by dt, 30 millicoulomb, and you can get 0. So for B, current is 0 basically. Therefore the current from, because 6 is between 8 and 2, so the current is basically, we can see the current from t 2 to 8, or we can say 8 to 2 is 0. For point C, as we know, now you are going like this, we have 2 points, this. So here q minus 30, q minus 30 millicoulomb equal to, no, this is 0 minus 30, this was 30 minus 0, now this is point x2 minus x1 and y2 minus y1, as you know. So from this point to this point, so 0 minus 30 millicoulomb and 12 minus 8. Or we can say t minus 8 millisecond. So this will become, easily we can say, the minus 30 divided by 4, minus 7.5 into ampere base, t minus 8 millisecond and plus 30 q. So however, as we know, I is equal to dq by dt. So this would become what, minus 7.5 multiplying this with t, so minus 7.5 d by dt, I can directly write here, minus 7.5 t plus minus 7.5 minus 8 would become 60 and plus 30. So, and 60 plus 30 would become 90. However, after taking differential, this whole term will become 0, and d by dt is equal to d by dt minus 7.5 t. This would become minus 7.5 ampere. So at t is equal to 10 millisecond, current is 7.5 ampere.